Hey everyone, welcome to the second part of chapter 1 video lecture, and today we're going to talk about how our computers store data. So one of the concepts that we need to get familiar with is that all data is stored on a computer in zeros and ones. Everything that you see, videos, pictures, text, does not matter. Everything is translated into zeros and ones eventually. So a computer's memory is divided into tiny storage locations known as bytes, and one byte will represent one number. Important to know, one number. And a byte is divided into 8 small storage locations that are known as bits, or we also call them sometimes binary digits. And this is what I want you to think of, this picture right here. This is what it would look like. So bits are just tiny electrical components that can hold either a positive or a negative charge, and then a positive charge would be similar to a switch in the on position right here, positive, and then a negative, the opposite, off. It's easy, right? Nothing too hard so far. Now, the positive charge that is in the on position is what we refer to as 1. Then the negative charge we refer to as 0. Sometimes we also refer to 1 as true and 0 as false. I'm sorry, my mouth is glitching right now. I don't know what's wrong with it. So 0 is false, 1 is true. This is what we call a binary system, and binary comes from 2, as in bi, so 0 and 1, binary. Whenever we want to store a number using our binary system, this is how we would do. Each digit in a binary number has a certain value assigned to it. How I do it, I just look at the position of the numbers. So, starting with 0, our first position is 2 to the power of 0. Then our second position is 2 to the power of 1. 2 to the power of 2, to the power of 3, 2 to the power of 4, so on, so on, and so on. And the last number will be 2 to the power of 7. Now, how do we calculate our numbers, you might ask me? And this is an example here. So, if you see a 0, you just skip that number, because remember, 0 is false. So, if you're trying to multiply anything by 0, you will get a 0. So we just skip them. So all you need to do is to look at the ones that you have. See which position your 1 is located at. So we have 1 at the position of 0, then we have 1 at the position of 2. See, 0, 1, 2. Then we have 1 at the position of 3, 4. Then again, we skip these in the position of 7. So all you need to do is take those ones and just multiply them by the power of 2 to the position that this is located at. So here we have 1 multiplied by 2 to the power of 0, which is 1. Then we skip this one, and then we move on to the next one. Then we multiply 1 to the power 1 multiplied to the power of 2, 2 to the power of 2, which is what? 4. Then we move on to the next one, 1 multiplied to 2 to the power of 3, which is 8. And so on and so on, to the power of 4 to the power of 7, which is 16 and 128 respectively. And this is what we're going to end up with, 157. The largest value that you can store in a byte with 8 bits is 255. And then if you use 2 bytes, they're used for larger numbers, your maximum value goes up to 65,535. Here's an example where those numbers came from. So this number right here on this side is 255. And if we add another 8 bits to it, we're going to end up with 65,535. So whenever we want to store characters, we store them using certain code. Okay, so we have ASCII, which stands for American Standard Code for Information Interchange, and ASCII has a number that represents each character, capital letters and lowercase letters. So ASCII is a set of 128 numeric codes, but ASCII is limited. That's its problem, that it's only for English language. However, we also have Unicode. Unicode is an extensive encoding scheme, and it is compatible with ASCII, but it also represents characters for many other languages that exist in the world. Here are some other types of data that are stored in binary. So digital data, this is what we call anything that is stored in binary. Then a digital device is any device that's going to work with your binary data, and also digital images that are composed of some tiny dots of color. We call it pixels, which comes from picture elements. And then digital sound is broken into smaller pieces that are known as samples. So moving on, we're going to talk about how a program works from the inside. So a computer CPU, it can only understand instructions that are written in machine language. Now I'll show you an example of machine language in a little bit. But machine language is really, really hard to write programs in. Trust me, I had to write a couple of them. It was horrible. I hated every second of it, because you have to imagine that machine language is basically the first language that the computer spoke in, okay? Before all of those other programming languages have been created, we had only machine language. But from machine language, we have now other programming languages, which make our life much easier. So a little bit of information about the CPU. As I said before, the most important component in a computer is a CPU. They don't call it a brain, but if you imagine it as a brain that you control, you can think of it that way. But CPU is not smart. That's why in the book they're saying that it's not a brain, just because it's not smart. It cannot think for itself. It's just a device that is designed to do certain things. So these are all the operations that the CPU can do. It can read a piece of data from main memory. It can add two numbers. It can subtract one number from another number. It can move a piece of data from one memory location to another. It can determine whether one value is equal to another value. So there's a bunch of things the CPU can do, but you have to remember that it will not do that unless you tell it specifically to do so. So your CPU will only understand instructions that are written in machine language. And machine language, this is where our binary system comes to play. Machine language is instructions that are written in ones and zeros. And the entire set of instructions that a CPU can execute, we call it the instruction set. And each brand of your microprocessor, such as Intel, AMD, Motorola, it has a unique instruction set that it can do. So let's get familiar with the fetch, decode, execute cycle. And this is just a term that we use to explain what happens when the CPU executes any instructions that are in the program. So fetch, right here, fetch is the first step. It's where we just get the instructions from the program, right? We get this number from the program into CPU. Then decode means that CPU looks at its instruction set and it looks at it and it searches for the same number that it just fetched. It searches for the same number, and then once it finds a match, it knows what to do, because this number represents an action that the CPU should do. And then the third step, the last one, execute. Just perform whatever the CPU needs to do. Okay, so how do we get to machine language, right? From our languages. So since computers can only understand machine language, people came up with something that makes their life a little bit easier. And it all first started with assembly language. And assembly language is just a language that uses short words that we call mnemonics. And then it also has an assembler that translates those short words into machine language, zeros and ones. This is what it would look like. So this is a program written in assembly language. So move some variable to location Z, then add to this variable 2, and then move some other variable to the location where our first variable was located. And what it would do, the assembler would take these instructions and it would create zeros and ones that represent the same instructions in machine language programming. So assembly language is referred to as a low-level language, but high-level languages is something that you will write programs in. It's Java, C++, Python, C#, and so on. Here are some keywords that we need to learn. So keywords or reserved words, they have specific meaning and purpose in the programming language. So for example, it's a word that whenever you type it to the computer will know exactly what to do. You don't have to say anything else to the computer. If you say that reserved word, there will be some action that your CPU can perform. Then operators is just something that will perform various operations on data. Then syntax is a set of rules that you as a coder must strictly follow when you're writing a program. And each programming language has its own syntax. So you have to be aware of that, because not every programming language will have the same syntax and the same keywords or the same reserved words. Everything is different. And then statements. Statements are just individual instructions that you write in any programming language that you desire to. So any statements that you write in any of the high-level language, such as Python or Java or C#, we call it a source code, or just simply you call it code. But if you hear source code, you will know that people just refer to it as code. So then that source code is taken and translated into machine language using a compiler or interpreter. Now, let's cover a little bit of the syntax errors and what that is. Syntax errors usually happen when you either misspell a word, when you miss a punctuation character, or if you incorrectly use an operator. Compiler, the difference between the compiler and interpreter. Compiler only translates your code into a machine language code. However, an interpreter translates and executes the instructions of your high-level language program. So that's the only difference between the two. Compiler only translates and then just sends your machine language program somewhere else. And then interpreter both translates and then executes those instructions. This is all I had for today. This is chapter 1. Next video, I'm going to be covering chapter 2, part 1. Thank you.